Hello, today we are doing class 9 mathematics and the chapter we'll do is indices, and the form of writing indices is your a to the power m, where m is your index or power, or we can also call exponent, and a is our base. So from here we understand how many times the base is being multiplied. For example, 2 to the power 3 can be written as 2 into 2 into 2 equals to 8. Clear? And indices is a plural of index only. And once you understand some rules and the laws of indices, your maths will be very easy. First we'll do the laws or rules of indices. The first one is here: when like terms are multiplied, powers are added. So if you see that a to the power m into a to the power n, our bases are same. When the bases are same, they are considered as like terms. And when like terms are multiplied, powers are added. A to the power m plus n. Let's take one example. 2 to the power 2 into 2 to the power 3. This will give you, both are 2, bases are 2, so these are like terms. 2 to the power 2 plus 3, this will become 2 to the power 5, which equals to 32. Second, when the like terms are divided, powers are subtracted. Okay, so it is division. So this can be written as a to the power m minus n, or division we can write in another form also, a to the power m divided by a to the power n. This can also be written as a to the power m minus n. So let's take one example. 5 to the power 5 divided by 5 to the power 3. This will give you 5 to the power 5 minus 3, this will be 5 to the power 2, which is 25. Clear? And the third rule is here: a to the power m whole to the power n. This can be written as, when you find this kind of question, here you have to write a to the power m into n. So that means here a to the power m whole to the power n, that means these powers will get multiplied. Okay, example: 2 to the power 2 whole to the power 3. This will give you 2 to the power 2 into 3. This can be written as 2 3 are 6. So 2 to the power 6, which will be 64. Clear? And rule number 4 is here: a b whole to the power m. So we have two terms inside the bracket, or in the bracket we have two terms, and there is one power m. So this, we can split these powers. This will be written as a to the power m into b to the power m. Clear? Let's take one example here. 2a whole to the power 2. If you have here, this will be written as 2 to the power 2 into a to the power 2. This will become 2 to the power, 2 to the power 2 is here 4 a square. Clear? And another is here, rule number 5 is here: a by b whole to the power m can be written as a to the power m divided by b to the power m, or this can also be written as a to the power n divided by b to the power n. If you have this, when we have numerator and the denominator with same power, then they can be written within the bracket a by b whole to the power n. Clear? So let's take one example here. 2 by 3 whole to the power 2 can be written as 2 square upon 3 square. This can be written as 2 2 are 4, 3 3 are 9. Rule number 6. So a to the power minus m. You can see here the power is minus m. So that means the power is negative. When the power is negative, the base will be reciprocal. It will be written as 1 by a whole to the power m. This can be written as 1 by a to the power m. Or if you have a by b whole to the power minus m, this can be written as, so here we can notice that when the power is negative, the base got reciprocal. Here also we just have to reciprocal the base, b by a whole to the power n. Okay, let's do one example. So if we have 2 to the power minus 3, this can be written as 1 by 2 to the power 3. This can be written as 1 by 8. Okay, or if we have 5 divided by 2 whole to the power minus 2, this can be written as 2 by 5 whole to the power 2. This can be written as 2 to the power 2 is a 4, 5 to the power 2 is a 25. Rule number 7. A to the power m is equals to a to the power n. When the equation has the same base, the powers will be equal. This will give you m is equals to n. For example, so if I write here 2 to the power x is equals to 2 to the power 5, then we can write, therefore, if you have to find the value of x is equals to 5, since the bases are same. Clear? Similarly, rule number 8, if we have a to the power m is equals to b to the power m. Now, the just little difference here, a to the power m, b to the power m. Here you notice that powers are same, the bases are not same. Here, when the powers are same, then their bases are equal. Will be a will be equals to b. Example, we can write x to the power 5 is equals to 7 to the power 5. We can notice there the powers are same, therefore x is equals to 7. Clear? And 9. Sometimes we will get this a to the power m, b to the power n is equals to a to the power x, b to the power y. So when we see the positive numbers with different powers, we can see here the basis. When we have the same basis by this a, basis a, powers are same. So from here we can write here m is equals to x and n is equals to y. Example, we can write here a to the power x, b to the power y is equals to a to the power 5, b to the power 7. Then we can write here x is equals to 5 and y is equals to 7. Clear? And number 10 here, so this is very important, a to the power 0 is equals to 1. Any number to the power 0 is 1. Example, we can take here 2 to the power 0 is equals to 1. 100 to the power 0 is equals to 1. Any number, any odd numbers you can take, 2, 7, 3, 4, 5, whole to the power 0 is equals to 1. Okay, either positive, negative, any number to the power 0 is 1. Okay, 11 root under a can be written as a to the power half. When we write root under, this means the power is half. Just example here, root under 25. This means here 25 has the power half and 25 will be 5 square into half. This get cancelled, then we have 5. So we just have to understand when any number is written under root, it has a power and the power is a half. Okay, so number 12 is a n root under a can be written as a to the power 1 by n. So any number, if it is written here, this is the denominator of the power. Clear? So this can be written like this. So example here, 3, 8. Okay? This can be written as 8 to the power 1 by 3. So this can be written as 8 is here 2 into 2 into 2. 2 to the power 3 into 1 by 3. This get cancelled. So you get the value 2. And 13 last. So if it is written in a whole to the power m, this can be written as a to the power 1 by n whole to the power m, or simply this can be written as a to the power m by n. Now we have completed all the important rules of indices, and I suggest you to practice these rules or the laws and understand its concept so that it will help you to do your mathematics more easily and conveniently also. Let's solve some questions to understand the laws of indices better way. Okay, question number 1, 81 divided by 16 whole to the power minus 3 by 4. So here if you have noticed, the power is negative. In order to make this positive, we will reciprocal the base. 16 upon 81 whole to the power 3 by 4. We have done thus earlier. A to the power minus m is equals to 1 by a to the power m. Here you can see that power has denominator 4. So whenever you have the denominator in the power, so at that time you have to check your base. Base always has the power similar to the denominator as per your class level. Okay, so 16 will be how much? 16 can be written as 2, 8, 2, 4, 2, 2. So 16, 1, 2, 3, 4. 2 to the power 4 is a 16. Similarly, 81 can be written as 3, 27, 3, 9, 3, 3. 1, 2, 3, 4. So 3 to the power 4 will give you 81 whole to the power 3 by 4. So this can be written as 2 by 3 whole to the power 4 into 3 by 4. Since we have done just earlier that a by b, a to the power m divided by b to the power m can be written as a by b whole to the power m. Clear? So this 4 will get cancelled, then we will get 2 to the power 3 divided by 3 to the power 3, which is here 2 to r 4, 4 to r 8, 3 to r 9, 9 to r 27. Next question is here a to the power minus 1 plus b to the power minus 1 whole divided by ab to the power minus 1. So first we'll make the power positive. 1 by a plus 1 by b whole divided by 1 by a b. Okay, so here we have written here a to the power minus 1 is equals to 1 by a, or a to the power m is equals to 1 by a whole to the power m. So we have reciprocal the base. Clear? So this is equals to, you take the LCM of these two. LCM of these two will be how much? A, b, b plus a whole divided by 1 by a. So here, sorry, a, b. If you see here, both has, numerator has the denominator, denominator has the denominator, which is same. We can have this cancel. Then we'll get here b plus a divided by 1, which is equals to a plus b. So how we'll get here? This can be done like this way: b plus a divided by ab into, so this will be reciprocal, ab divided by 1. This will get cancelled. So this from here we get b plus a divided by 1. And the next question we have 3a divided by b to the power minus 1 plus 3b divided by a to the power minus 1. This can be written as 3a whole divided by 1 by b plus 2b whole divided by 1 by a. Okay, so here this can be written as denominator will go up, this will become 3ab plus 2ab. So I'll just do 3a divided by 1 by b can be written as 3a into b divided by 1. This will give you 3ab. Clear? And similarly we will do for this one also. So, or else directly when there is a denominator only one term, we can multiply it. Okay? Both are similar terms, ab, ab. So 2 plus 3 is here 5ab. This is the answer. Next question we have is here 5 to the power 0 into 4 to the power minus 1 plus 8 to the power 1 by 3. This can be written as 5 to the power 0, any number to the power 0 is 1 into 1 by 4 plus 8 can be written as 2 to the power 4, 4 to the power 8, 2 to the power 3 into 1 by 3. So what we have done here, a to the power 0 is equals to 1 is one rule. Okay, it is not required to do, but for now you can write the laws so that it will be easy for you to remember or use the law. Okay, and a to the power minus 1 is equals to 1 by a. These two laws we have used here. So this 3 and 3 will get cancelled. Then you will get here 1 1 1 divided by 4 plus 2 to the power 1 is here 2. Then take the LCM. LCM here nothing means it always has the denominator 1. So 4 into 1 is here 4. 1 1 are 1, 4 2 are 8. This will become 9 by 4. So we never leave the answer in the improper fraction. We'll make this proper. This is here 4 will multiply 9, 4 2 are 8, 1. So this 1 will go up, this will come in. So this will be 2 1 by 4. So this is the answer. Okay. The next question is here 5 into 25 whole to the power n plus 1 minus 25 into 5 to the power 2n. Here 5 into 5 to the power 2n plus 3 minus 25 to the power n plus 1. Okay, this is very important question. Usually this questions comes in the examination. So how do we solve here? Let's see. All has the basis. We can make the basis same. 25 is the multiple of 5. So first we will do here 5. This is into 25 can be written as 5 square into n plus 1 minus 25 can be written as 5 square into 5 to the power 2n whole divided by, this is a 5 into 5 to the power 2n plus, since we are getting 2n and 2, so 3 can be written as 2 plus 1. Clear? Minus 25 can be written as 5 square n plus 1. Okay, now we will just open the bracket. 5 to the power 2n plus 2 1 are 2 minus, when the like terms are multiplied, powers are added. So a to the power m into a to the power n is equals to a to the power m plus n. This rule we use here. So this will be a 5 to the power 2n plus 2. When the like terms are multiplied, powers are added. And here, so if we write here 5 to the power into 5 to the power 2n plus 2 into 5. We can write here. So if we have here 5 to the power 2n plus 2 plus 1. 2 plus 1 is nothing, this is 3. Okay, so we know that when the like terms are multiplied, powers are added. Similarly, if we have 5 to the power 2n plus 2 into 5 to the power 1, so how we'll write this? This can be written as 5 to the power. Bases are same. When the like terms are multiplied, powers are added. This will become 2n plus 2 plus 1. So this is similar to this. So from this we can split this into 5 to the power 2n plus 2 into 5 to the power 1. Okay, so we have to split this into 5 to the power 2n plus 2. So if you see here, all these terms, 5 to the power 2n, 5 to the power 2n plus 2, 5 to the power 2n plus 2, 5 to the power 2n plus 2 are same. So we can take this common, 5 to the power 2n plus 2. When we take this common, remaining will be here 5. Here remaining will be minus 1. Here if you take 5 to the power 2n plus 2 common, how much is the remaining? This 2 5. 5 into 5, 25 minus, okay, this whole term we have taken common, so 1. So here if you notice these two terms are similar, we can have these two terms cancel, then remaining will be 5 minus 1 is here 4, 25 minus 1 is here, sorry, 24. Now 4 1 are 4, 4 6 are 24, this will give you 1 by 6. Next question is 3 to the power 2 whole to the power 0 plus 3 to the power minus 4 into 3 to the power 6 plus 1 by 3 whole to the power minus 2. Okay, to solve this we will do here, any number to the power 0 is 1 plus when there is negative sign, so we will make this positive, this will become 1 by 3 to the power 4 into 3 to the power 6 plus, so when the power is negative we will make it positive, so this will become 3 to the power 2. Okay, reciprocal the base, we have reciprocal the base, you can see here. Okay, since we can write here a to the power minus m is equals to 1 by m. This rule we have used here, 1 plus, also we have used rule a to the power 0 is equals to 1. So these are division. Okay, when the like terms, so both has the base 3, when the like terms are divided, the powers are subtracted. This can be written as 3 to the power 6 minus 4 plus 3 squared. This can be written as 1 plus 3 to the power 2 plus 3 3 are 9. 1 plus 9 is here 10 plus 3 3 are 9 is equals to 90. Next question we have is 81 to the power 3 by 4 minus 1 by 32 to the power minus 2 by 5 plus 8 to the power 1 by 3, 1 by 2 to the power minus 1 to the power 0. We solve this. So already told you, whenever there is a denominator in the power, we have to check the base. Base will have the same power. This 81 is the what? We can write 3 to the power 4. 3 to the power 4 is 81 whole to the power 3 by 4 minus, so first make this positive, the power positive, so this will be 32 divided by 1 which is 32, 2 by 5 plus 2 to the power 3 into 1 by 3 we can write, so this also we can write into 1 by 4, so they make this power positive, 2 to the power 1, any number to the power 0 is 1. Clear? So we have this 4 cancel and 3 get cancelled, so this will become 3 to the power 3 minus 32 can be written as 2 to our 4, 4 to our 8, 8 to our 16, 16 to our 32, or else you can factorize this. This will become 2 to the power 5 into 2 by 5. So all the denominators of the power is being cancelled, plus 2 into 2 into 1. Okay, this will become 3 3 are 9, 9 3 are 27 minus, this will get cancelled, 2 2 are 4 plus 2 2 are 4. So both are plus 4 minus 4, we can have this cancelled, the answer will be 27. The next question is 64 divided by 125 whole to the power minus 2 by 3 divided 1 upon 256 upon 625 whole to the power 1 by 4 plus root under 25 divided by cube root under 64 whole to the power 0. Okay. So now again, first what we have to do, we have to make this power positive. So we'll make this 125 divided by 64. We reciprocal the base, the power will become positive divided by 1 upon. So if the power has denominator, the base will have the power equal to the denominator of the power. So 256, 56. Okay, actually this is the power of 4. Okay, 4 times. Anyways, we can do this way. 2, 1 are 2, 2, 2 are 4, 2, 8 are 16, 2, 6 are 12, 2, 4 are 8, 2, 3 are 6, 2, 2 are 4, 2, 16, 2, 8, 2, 4, 2, 2. Now if you notice 1, 2, 3, 4, 4, 4, 4, 4. 4, 4 are 16. Okay, so that means 4 to the power 4 is your 256. This can be written as 4 to the power 4. And similarly, we can find this 625 is your 5 to the power 4 whole to the power 1 by 4. Plus any number to the power 0 is 1. From here, we'll get directly 1. Any number to the power 0 is 1. This is equals to, again, 125. The power of 5 is 5 to the power 3 is 125, 5 to the power 3, and here 64, after 64 if you see that 1, 2, 3, 4 to the power 3 is here 64 whole to the power 2 by 3 divided by, this can be written as 1 upon 4 divided by 5 whole to the power 4 into 1 by 4 plus 1. So we can have this 4 cancel. Here also 5 upon 4 whole to the power 3 into 2 by 3 divided by, this can be written as 1 upon 4 upon 5 plus 1. These 2 will get cancelled. So 5 to the power 2 is here 25, 4 to the power 2 is here 16 divided by 5 will go up, 5 upon 4 plus 1. This is equals to 25 divided by 16 into, this will be reciprocal, 4 upon 5 plus 1. 5 1 are 5, 5 5 are 25, 4 1 are 4, 4 1 are 4, 4 4 are 16. This will become 5 upon 4 plus 1. Then we'll take the LCM, 4. 4 1 are 4 plus 5 is here 9. This can be written as 2 1 upon 4. So if you have like this 5 upon 4 plus 1, if you take the LCM, this will be 4. This will be a 5, 4 1 are 4. 4, this is equals to 9 divided by 4. So anyway, if you find like this, we can directly do 4 1 are 4 plus 5. Okay, if it is minus 4 1 are 4, 5 minus 4 is here 1. This way you can do directly. Clear? Next question, we have 3 to the power n into 9 to the power n plus 1 divided by 3 to the power n minus 1 into 9 to the power n minus 1. Okay, so we'll try to make the bases same, which will be easy for us to solve. So this can be written as 3 to the power n into 3 to the power 2 n plus 1 divided by 3 to the power n minus 1 into 3 to the power n into n minus 1. Okay, whole bracket we can write here. So make it more simple, 3 to the power n into 3 to the power 2n plus 2 divided by 3 to the power n minus 1 into 3 to the power n square. N into n, sorry, this is a 2n minus 2 1 are 2. So when the like terms are multiplied, powers are added. This will become 3 to the power n plus 2n plus 2 divided by 3 to the power n minus 1 plus 2n minus 2. Okay, this will become 3 to the power 3n plus 2 divided by 3 to the power, this is a 3n, both are minus, this will be minus 3. Clear? So when the like terms are divided, powers are subtracted. 3 to the power 3n plus 2 minus 3n minus 3. This will be written as 3 to the power 3n plus 2 minus 3n minus plus 3. Okay, so then we have this plus 2n, 3n and minus 3n cancel. This will become 3 to the power 5. 3 to the power 5 is how much? 3 3 are 9. 9 3 are 27. 27 3 are 81. 81 3 are 243. 243 is the answer. Question number 10 is x to the power a plus b whole divided by x to the power c whole to the power a minus b into x to the power b plus c whole divided by x to the power a whole to the power b minus c, x to the power c plus a whole divided by x to the power b whole to the power c minus a. This can be written as, we will separate this. We know one rule that a to the power m, a by b whole to the power m can be written as a to the power m divided by b to the power m. We use this law, so this can be written as x to the power a plus b divided whole to the power a minus b whole divided by x to the power c into a minus b. Clear? Into, okay, I'm writing this sign into x to the power b plus c into b minus c. So this will multiply, and again x to the power a into b minus c into, this is x to the power c plus a whole to the power c minus a whole divided by x to the power b into c minus a. Okay, now if you notice here, this is a plus b, a minus b. This is also same, b plus c, b minus c, a plus b, a minus c. This is also in the same. So we know that since a plus b, a minus b is equals to a square minus b square. This is the product formula of a square minus b square. Here x to the power a plus b, a minus b can be written as x to the power a square minus b square using the formula whole divided by x to the power ca minus bc into x to the power b square minus c square whole divided by x to the power ab minus ca into x to the power c square minus a square whole divided by x to the power bc minus ab. Clear? Now, if you just see the numerators and the denominators separately, when the like terms are multiplied, powers are added. X to the power a square minus b square plus b square minus c square plus c square minus a square. We are just writing the powers only. Similarly, when the like terms are multiplied in the denominator, powers are added. X to the power ca minus bc plus ab minus ca plus bc minus ab. Okay. Now see here, a square minus a square plus a square minus b square plus b square minus c square plus c square cancel, plus ca minus bc plus bc plus ab minus ab will get cancelled. Then whole term get cancelled. X to the power 0 divided by x to the power 0, which is equals to 1 by 1 equals to 1. The next question is x to the power a divided by x to the power b whole to the power a square plus ab plus b square, x to the power b divided by x to the power c whole to the power b square plus bc plus c square, and similarly x to the power c divided by x to the power a whole to the power c square plus ac plus a square. For this question we have to know one product formula, that is here a cube minus b cube is equals to a minus b, a square plus ab plus b square. This is the product formula of a cube minus b cube. For solving this, we need to use this formula, okay? And if it is plus, this will become plus, this will become minus, okay? So here, this is equals to, when the like terms are divided, powers are subtracted. X to the power a minus b into a square plus ab plus b square into, I'm writing into sign, x to the power b minus c whole to the power b square plus bc plus c square into x to the power c minus a into c square plus ac plus a square. Okay, so all these are in the same formula, a cube minus b cube. So this can be written as x to the power a cube minus b cube into x to the power b cube minus c cube into x to the power c cube minus a cube. When the like terms are multiplied, powers are added. X to the power a cube minus b cube plus b cube minus c cube plus c cube minus a cube. If you see here, plus a cube minus a cube get cancelled, minus b cube plus b cube minus c cube plus c cube, all this will get cancelled. This will be nothing, x to the power 0, any number to the power 0 is 1. Okay. Next, we have 1 divided by 1 plus a to the power m minus n plus 1 divided by a to the power 1 plus a to the power n minus n. So, here this can be written as 1 divided by 1 plus a to the power m upon a to the power n. So, if I write here a to the power m divided by a to the power n, when the like terms are divided, powers are subtracted. This can be written as a to the power m minus n. So, for a to the power m minus n, we can write a to the power m divided by a to the power n plus 1 divided by 1 plus a to the power n divided by a to the power m. So, this will be 1 divided by, take the LCM here, a to the power n, a to the power n, this will be a to the power n plus a to the power n plus 1 divided by a to the power m plus a to the power n whole divided by a to the power n. We have taken the LCM here. So this will go to the numerator, this will become a to the power n divided by a to the power n plus a to the power m plus this will also, this is going to the numerator. This will go to the numerator. A to the power m divided by a to the power m plus a to the power n. So a to the power n. So we have the same denominator. So we can take the common, LCM a to the power n plus a to the power m. Here also we will get a to the power n plus a to the power n. So put them in the bracket and we can have the similar terms cancel. Okay. Then this will be 1 upon 1 equals to 1. Okay. If you get confused here, from here we can see this 1 divided by a to the power m plus a to the power m whole divided by a to the power n. This can be written as 1 into reciprocal a to the power n, a to the power n plus a to the power n. If you multiply whole term to 1, you will get this term directly. Clear? Next question, question number 13. If a is equals to c to the power z, b is equals to a to the power x, and c is equals to b to the power y, prove that x, y, z is equals to 1. So we can write here solution. Here it's given that a is equals to c to the power z, okay, and b is equals to here, and b is equals to a to the power x, since a, the value is a is equals to c to the power z, or b can be written as a to the power, a we can replace, which will be c to the power z whole to the power x Therefore, b is equals to c to the power x z. Also, it is given that c is equals to b to the power y, or c is equals to, by replacing the value of b, what will get? C to the power x z whole to the power y. Therefore, c is equals to c to the power x y z. Or, so if you write the number simple, if there is no power, we can always write the power 1. A to the power 1 is here, a only. So we can write here c to the power 1. Okay, or this can be written as 1 is equals to x y z. We know that same basis, since a to the power x is equals to a to the power y, then we can write x is equals to y. When the bases are same, powers are equal. Therefore, we can write here x y z is equals to 1, hence proved. Next question is, if 2 to the power x is equals to 3 to the power y equals to 12 to the power z, prove that x is equals to 2yz divided by y minus j. In this kind of questions, we have to take the supposition. Okay, we will take let 2 to the power x is equals to 3 to the power y equals to 12 to the power z is equals to k. If we take supposition, then we can write here 2 to the power x is equals to k. Therefore, 2 is equals to k to the power 1 by x. So how we'll get this is by multiplying. So if I have 2 to the power x is equals to k, if I multiply both sides by 1 by x, 2 to the power of 1 by x, x into 1 by x is equals to k to the power 1 by x, then x will get cancelled, then 2 will become k to the power 1 by x. Clear? Similarly, 3y is equals to k, therefore 3 is equals to k to the power 1 by y, and 12 to the power z is equals to k, therefore 12 is equals to k to the power 1 by j. So we have 12 is equals to 1 k to the power 1 by z, or 12 can be written as 2, 6 are 12, 2, 3 are 6. So 12 can be written as 2 into 2 into 3, can be written as 2 square into 3. For 12 we can write 2 to the power 2 into 3 is equals to k to the power 1 by z. We have already got the value of 2 and the 3. 2 is here, k to the power 1 by x whole to the power 2 into 3 is here, k to the power 1 by y is equals to k to the power 1 by z. Or this can be written as k to the power 2 by x into k to the power 1 by y is equals to k to the power 1 by z. Or when like terms are multiplied, powers are added. This can be written as k to the power 2 by x plus 1 by y is equals to k to the power 1 by z. Or when the bases are same, powers are equal, so we can write here 2 by x plus 1 by y is equals to 1 by z. Since we can write here a to the power m is equals to a to the power n, can be written as m is equals to n. Clear? Or we can do here 2 by x is equals to 1 by z. This will go on the side, minus 1 by y. Clear? Or we can write here 2 by x is equals to, if we take the LCM y z, this will become y minus z. Or cross multiplication. Okay, so if you multiply these two and these two, this will become x into y minus z is equals to 2yz. Therefore, x is equals to 2yz whole divided by y minus z. This we have to prove. We got the value, so we write here hence proved. Here, and the next question is here 15 cube root under a to the power 6 b to the power minus 4 is equals to a to the power x into b to the power 2y. Find x, y where a and b are the two positive numbers. Or this can be written as a to the power 6 b to the power minus 4 whole to the power 1 by 3, because cube root is 1 by 3. If this means denominator of the power a to the power x into b to the power 2y, or this can be written as a to the power 6 into 1 by 3 into b to the power minus 4 into 1 by 3 equals to a to the power x into b to the power 2y. Or 3 1 are 3, 3 2 are 6. This will become a to the power 2 into b to the power minus 4 divided by 3 is equals to a to the power x into b to the power 2y. Since we know that suppose if you have a to the power m and b to the power n is equals to a to the power p and b to the power q. So from here we'll get the m is equals to p and n is equals to q. Clear? This is just the law only. So here also we have the same basis a and the b. So we can write here, thus we can write here 2 is equals to x, therefore x is equals to 2, just taking a, and the remaining if you take means this will be minus 4 by 3 is equals to 2y. 2 1 are 2, 2 2 are 4, therefore y is equals to minus 2 divided by 3. This is how we will get the value. Next question we have 5 to the power 2x plus 3 equals to 1, and we have to find the value of x, or this can be written as 5 to the power 2x plus 3 is equals to 5 to the power 0. Any number, we know that any number to the power 0 is 1. Since a to the power 0 is equals to 1. For 1 we can write 5 to the power 0 in order to make this basis same. Okay? When the bases are same, their powers are equal. So we can write 2x plus 3 is equals to 0. Since a to the power m is equals to a to the power n can be written as m is equals to n. Clear? So, or we can write here 2x is equals to minus 3, or x is equals to minus 3 by 2. So we can leave the answer here. Similar question we have 13 to the power root under x is equals to 4 to the power 4 minus 3 to the power 4 minus 6. So this can be written as 13 4 to the power root under x is equals to 4 to the power 4 is here 256 minus 3 to the power 4 is here 81 minus 6, or this will give you 13 4 to the power x is equals to 256 minus 81 minus 6. We'll get 169, or else we can write it 256 minus 81, 5, 15 minus 8 is here 7, and this is here 1 minus 6 will give you 961. So this will be a 169. Okay, or 13 4 to the power x is equals to 69 is a 13 into 13, 13 square. Or when the bases are same, powers are equal, root under x is equals to 2. Okay, so here we can write here a to the power m is equals to a to the power n is nothing, m is equals to n. So now we can do the squaring both sides. We get how much? X square is equals to 2 square this and this will get cancelled. Therefore, x is equals to 2 to the 4. Clear? See here, root under x whole square is nothing. X to the power half into 2. This can cancel. So we will get the value of x. Okay. Here, the next question we have: if 3 to the power x plus 1 is equals to 9 to the power x minus 2, find the value of 2 to the power 1 plus x. So here, if you get the value of x, we can find the value of this. So here, first we'll make the bases same, or this can be written as 3 to the power x plus 1 is equals to 3 to the power 2 into x minus 2, 3 square is here 9, or 3 to the power x plus 1 equals to 3 to the power 2x minus 2 to our 4. When the bases are same, powers are equal, or x plus 1 is equals to 2x minus 4. Here, since a to the power m is equals to a to the power n, can be written as m is equals to n. The same rule we are using. Or we'll bring the x together. X minus 2x is equals to minus 4 minus 1, or minus x is equals to minus 5, minus minus will get cancelled, therefore x is equals to 5. Thus, we can find here 2, 1 plus x is equals to 2 to the power 1 plus x is here 5 is equals to 2 to the power 6 is equals to 64. 2 to r 4, 4 to r 8, 8 to r 16, 16 to r 32, 32 to r 64. 2 to the power 6 is here 64. Next is here, solve the given equation. In order to solve this equation, we have to find the value of x. Or this can be written as, open the bracket, 3 to the power, 3 into 2 to the power x plus 3 1 are 3 minus, open this can be written as 2 to the power x into 2 to the power 2 plus 5 equals to 0. So here 2 to the power x into 2 to the power 2 is nothing. When the like terms are multiplied, powers are added. 2 to the power x plus 2. Okay? Or this will be a 3 into 2 to the power x plus 3 plus 5 constant, 3 plus 5 is here 8 minus 2 to r 4.2 to the power x is equals to 0. Or if you noticed here, this and this are the similar terms, because it is something like 3 into 2 to the power x minus 4 into 2 to the power x. So if you consider this as variable like a, b, c, any term, then we can write 3 minus 4 is here 1 is here minus, see the bigger term is minus, so this is minus 2 x to the power, 2 to the power x. So from here we will get minus 2 to the power x is equals to 8 will go other side, minus 8, minus minus will get cancelled. 2 to the power x is equals to 8. So we have to make the same base, so we write the power of 2. So power of 2 to the power 3 is here 8. Therefore x is equals to 2. Since a to the power m is equals to a to the power n, therefore we can write n is equals to n. With this sum, we have solved all the important and the different type of questions from this chapter. Hope this will help you to understand the chapter indices clearly. Thank you.